This conference will now be recorded.
Yeah, good morning. So in the last session we have covered a couple of things, right? So if we summarize quickly what we have discussed, so we have seen the functional programming concepts, right? We have seen the functional programming concepts. Then we have started with object-oriented concepts, right? Object-oriented concepts. And as part of this, we just created a class, and created an object, and say we have seen an example, right? So, and today's plan is, so we'll get into this object-oriented concepts a bit more, right? So let us write a couple of programs and let us work with different scenarios of object-oriented. Okay. So the first thing, we have already know how to define a class. So theoretically, we have discussed already what is class, what is object, right? Now let us start how to define a class, and let's move on to different uh, ways, or you can say scenarios or cases. Okay, so let us create a class. How to create a class in Python? So we have a special keyword called class. With the help of this keyword, we can create a class. So so class a employee, and class followed by class name, and then colon. Colon represents the block of statements, right? So here indentation matters, so just give one tab space here and define whatever the variables you want, what are the functions you want to define. And just for your information, in Python, or in general most programming object oriented programming languages, right, the functions inside a class is known as methods. So from right now I use it to call the function as uh, a method. Okay, so a class is a group of, or a set of variables, and I can say a set of methods. I can say set of methods. I can say set of methods. All right. So let us talk about variables and methods, and what else we have. And we may have inside a class, we may have a constructor as well. We may have constructor as well. Then a typical template of class. So this is what a typical template of class. You can say this. Now, if you look at the variable part, so I'm talking about employee, right? So when you say employee, what are the general characteristics or properties of an employee we can see? So we can see every employee may have some ID, employee ID, and he may have employee name, right? So employee salary, date of joining, etc. So what are all these? All these are the characteristics or properties of an employee, right? So these are considered as a variables. These are considered as a variable, and we can define these variables. But where we can define these variables, we can define in different places. I'll show you one by one. And so as of now, I am not going to write many things over here. So let me have some documentation. Let me have some documentation at class level. So how can I give the documentation comments? So with the help of triple code, I can specify my doc codes. So this class it demonstrates the basic class template. Got it? So this is triple quotes, is known as multi-line comment in Python, and this is also used to define a documentation, to define doc lines. Okay. right? So now, so if I wanted to print this, right, I can I didn't define any constructor, I didn't define any variable, I didn't define any method, right? So I just given one doc comment. So if we wanted to see the documentation, so simply we can use the class name dot, we have something called doc, so run this. So instead of practice, if I give something else, right, maybe, what is that, employee, that's fine. So this is what it is, created a document. When I run this, right, it is created a document, and I can go with what, help. I can say help of student. I'm sorry, employee, right? It is employee. So here you can see that, okay. So it's going to tell you all about your class. Okay, so help on class employee in module, main module. So by default, it is considered as a main module, and the class employee, and it is going to extend this built-in object class, but we'll talk about this more when we are talking about inheritance. Okay, this by default, every Python class is going to extend one predefined built-in class. What is that? Object class. Okay, so what is the doc string here? This class demonstrates the basic class template, and here you can see a few more things. Dictionary. So the dictionary, this property is for what? Instance variables if we define, and so if it has any other class references, it's going to show. But anyhow, our class does not have anything, just a doc string I have defined, right? So see that. So now let's add one by one. So I have no variables defined here, right? Let me, I can define a variable. So how can I define a variable? Again, there are different types of variables. We have different type of variables. Okay, so we have instance variables instance variables, and we have static variables, and also local variables we have local variables we have local variables. All right. So these are the different kind of variables that we can use in our object-oriented programming or inside a class. Okay. So how we are going to operate, or how we are going to manage these variables in terms of declaring it, in terms of using it. Let us see one by one. Okay. So first thing is what? Instance variables. So instance variables are the variables specific to that particular instance. So an instance is also nothing but what? An object of employee class or some XYZ class, right? So if you look at this, so I have defined just a class. I define a class here. What is my class? Employee class. So my class is employee class. All right. So in general, what is class? A class is just a blueprint, right? It's a model, or it's a plan, right? So we can define a class as a model representation of a particular real-time entity. A real-time entity is nothing but what? An object. So basically, a class is a model representation of real-time entity. So here I have declared a class model, that is what, employee. And if I consider a particular specific employee, I'm talking about a specific employee. So now I can say this is an instance or object of that particular model, I can say when I talk about, right, a particular employee, when I talk about a particular employee, so this is nothing but an instance or object. Now, uh, so whom I am talking about? So I'm talking about a specific employee. So my employee, I'm going to create an object. How do we create an object in Python? So by making use of your class name followed by parenthesis. So when you call this, right, implicitly it calls the underlying constructor, which constructs your object, and it executes all initialization logic. So what initialization logic does? So it is going to initialize all your variables, right? So here, this is what my employee object. So here I can define, so employee name. So employee name. So employee name equal to, so Venkat. So what is, now I'm talking about a particular employee, right? Who is that employee? So Venkat. So I'm talking about a particular employee Venkat. Yeah, he existed in real world, right? So when we talk about a physical existing real-time entity, that is nothing but an instance or object. And if we model that particular object in terms of the characters of that particular object and the actions performed by that particular object, right? So that is where you can see a model the structure of that particular employee, right? So we are following that structure model and we are creating an instance. So this is one instance. So if I see this is a class model, and now this is one instance, and by using this particular class model I can create n number of instances. I can create n number of objects, yes or no? So I can create different objects. I can create, this is another instance, right? And this is another instance. So I can create multiple instances by using a specific model. That's what you can see, right? So these are the different objects. So here I can define my own objects again here. So I can define my own objects. So here a different object equal to, again I'm going to create what? Employee. So here also I'm going to create what? Employee. So now I'm having three employee objects. I'm having three employee objects or instances, right? So every object has its own name. Every object has its own salary, employee salary, date of joining. So every object has its own specific data. So here employee name is equal, so Shrikar, right? So here also I have employee name, e dot e name is equal to, I can define something else, Trikoti, right? So I have three employees. So here this is employee name value is Trikoti. Here employee name is Srikar and here employee name is Venkat. So this particular information is specific to this particular employee. So this is what is specific to object, specific to instance. So this ename is considered as instance variable. This ename is considered as instance variable, right? So yeah, so you got it. What is instance variable? So an instance variable is specific to instance. That's it. So this is also known as specific to object. Right. Let's define that instance variable first. So how do we define the instance variable? So I can make use of a special method here. I can make use of a special method here. So what is that? So underscore underscore init. So there is a special method here where I'm going to initialize my instance variables. Are we clear? Are you following, guys? Okay. So the next thing is, so I wanted to define the instance variable. So to define the instance variable, I need a instance. So then what is the instance here I'm going to take? So let me say ename is equal. Okay. So let me give Venkat. All right. So here, just observe here. So this is how I can make use of declaring a variable, instance variable, and I can give some value, right? So now the same object. Let me create an object. So I'll comment out this documentation section and all. All right. So here now I'm creating an object e equal to employee, e equal to employee, right? Equal to employee. Now let me run this. Let me run this. If I run, what will happen? Nothing happens, right? We don't see anything output. We don't see any output, right? Nothing. Why? Because I just created object, but I'm not printing anything. So here I have one instance variable. What is that? Ename. And ename is what? Venkat. So am I printing that? No. So if I wanted to print, I can make use of my a reference variable. So here e is nothing but instance uh, instance reference. So here you can see in general all the objects will create in all the objects create in heap memory. So we'll talk about this memory sections in detail in further session, but for now just have a quick idea about how memory model works. So here if you look at, all the objects are going to store inside a memory area called heap memory, right? All the variables are all the referenced variables are going to sit inside a stack memory inside a stack memory. And remember, in Python everything is an object. If I say one number x equal to 100, so x is equal when I say x equal to 100, so you might feel that this is a primitive type, but in Python that is also considered as an object, and as it is object it is going to sit inside this. So let us talk about that name only, employee name I have, right? So my employee object, where it is going to create inside a heap memory, and this is what e, right? E. So when an object is created inside a heap memory, so definitely it holds certain memory address, right? Say for example, so 100 200, this is what address, this is what uh, address address location inside your heap memory. And this address location is going to hold by your referenced variable. What is that referenced variable? I have a referenced variable e here. So e is pointing to this particular object, right? E is going to pointing to this particular object, and that particular specific address is going to hold here. What is that specific particular address? The address is what? 100 200 100 200. So now, so this is going to considered as a reference variable. The e is just a name, is just a name. We can describe that as a reference variable. Reference to what? This particular object. To access this particular object or object or data, instance data, we can make use of this particular reference variable. What is the reference variable here? E. So e will be pointing to this one. So in general representation, how do we uh, uh, how do we picture it? Just so here I have e, right? So e is a reference variable. E will be pointing to what? This particular object, this particular object. So this is generic diagrammatical representation, but if you look at the memory wise, so this is how it will be. So all your reference variables are variables. Memory address locations are going to sit inside a stack memory, and from that memory address, uh, at runtime, it is going to pick the values. When I say e values, so my employee is having what? E name now. So what value it has? It has a value of Venkat, right? It has a value of Venkat. So if I wanted to access this particular ename, I need, this is the instance, right? This is object. So I definitely need I definitely need this particular memory address location, where this memory address location resides in this particular variable. So with the help of this particular variable, I can make use of my employee name. But how? So there is a special operator. There is a special operator in Python, that is what? A dot. That is what? Dot. So with the help of dot operator, we can access the properties, characteristics, or methods of your particular object. So employee name. So e dot employee name. When I say e dot employee name, e is going to refer this particular address, and it goes to here. Inside this, I'm going to access what? E name. So e name is my instance variable. I'm going to access that instance variable with the help of e. What is e here? E is a referenced variable which is referring this particular instance, which is referring to that particular object. Is that clear? Is that clear so far? So please ping me in the chat window. Is there any confusion? Right. So here, let me execute this. Let me execute this and see. So here I can see the name as Venkat. Okay, this is fine. So this is fine. But now let me talk about one special thing here. What is that? Self. What is that here? Self. So in Python, the self is a special variable. Self is a special variable. We call it as a referenced variable. So in Python, self is a special referenced variable. Special referenced variable. So referring to what? Special referenced variable. Referring to what? Referring to the current underlying current underlying object. So this is how. So it represents the current underlying object, meaning what? Suppose I am calling e dot ename, right? E dot ename. So here, what is my current underlying object here? So the e is the current underlying object. So the reference what we are using to access the class variables or methods is known as current underlying object. So to represent this current underlying object, so I can make use of a special variable. What is that? Self. So this self or e both are same, right? Here in this case. So how it is going to treat? So see here, this when an object is created, what is happening? So I'll show you the debugging technique maybe after few classes. But now let's understand line by line. So here, this is a class. I have defined a class, and my class is having docstring. Then now I have started with what? Instance variables. So where I have declared my instance variable, I declared my instance variable inside this particular method. This is a function or not? We know that this is a function. But as we had defined inside a class, this is known as what? This is known as a method. This is known as a method. And also we call this as a constructor. So a constructor in Python is a special method. That's it. It is also a method. It is a special method. We call it as a constructor. And what is that name? Underscore underscore init underscore underscore double underscore. And this is a fixed one. This is a fixed one for each and every class. If I write employee class, student class, person class, animal class, if I define any class, the constructor name is not going to change. That will be common. And inside the constructor, whatever the variables you wanted to define, you can define it. You can declare and define. So here, so self.ename is just a declaration, and to that I'm defining or I'm initializing a value, Venkat. Clear? All right. So here, let's move on. So self variable. So we are going to talk about self variable, right? Let me have one print statement over here. Print statement. So executing constructor. Yes or no? So I just have a print statement. So and then after I have initialized ename. Now let me rerun this. See now. So the constructor is executed or not? The constructor is executed. So am I calling that constructor explicitly anywhere? No. I just created an object, right? This is what? Just creating an object. Creating an instance or object. Yes or no? Creating an instance. So when I create an instance, an object, then it automatically calls this particular specific constructor. It automatically or implicitly it executes this init. Okay, now let me have one more object. So this is one object, right? Let me have one more object. So now see again. So now for the first time it is called executing constructor. It has initialized the initialize in this is print logic. Okay, we are printing this one, right? That is the reason you can see this. Then again we have created one more object and again it is executing the constructor. So here the point is, right, so how many times you are going to create, how many times you create, so those many number of times the constructor will be executed. So what is the point here is, so in Python we have a special method. We have a special method. What is that method? Underscore underscore init. Init is nothing but a constructor. In Python we have special method known as a constructor. Is that point clear? And if you look at this, this is a fixed name. Okay, so and the constructor name is fixed for any class, meaning that it has the same name. It has the same name for every class. Then what is the other point? And it is mandatory. It is mandatory to have to have a parameter to have a parameter self to have a parameter self as a first parameter as a first parameter and it is mandatory to have that. It is mandatory to have at most one parameter in constructor definition that is a self variable. So you understand the points? Just I'm summarizing, that's it. So in constructor, it is must to have at least one parameter. What is that? It's at least, not at most. Okay, so at least one parameter. At least one parameter in constructor definition. What is that? Self. So let us see that. So if I don't give this self, what happens? Okay, if I don't give this a self, if I don't pass this self, what happens? So just execute it. So now you can see an error message, right? What is the error message? So type error init takes 0 positional arguments, but one was given. So meaning that, so this init, where is that? So this init, so it does not have any positional arguments, but it was given one, meaning that, so whenever you are creating an object, so it implicitly calls this particular method, we can say constructor. So it calls this constructor by passing a variable called self. So here meaning that, so it's going to send this particular variable implicitly. We don't have to send this explicitly by default. So when you create an object of any class, right? An object of any class, by default implicitly this will be passing as a parameter, as an argument, right? So that is the reason it expects to have that self parameter here, self argument here. Understand? So here, anyhow, one more clarification. So here, whenever you are defining a method or a constructor, here these are known as parameters, and when we are passing the data to that particular parameters, right? From here, this is what an argument. This is what an argument, right? So let us see. Let us focus on more. Now, by what is the point? When we create an object of your class, by default, as a first parameter, as a first argument, you can say, as a first argument, the self variable will be passed, right? What is the self? Self is a referenced variable that represents the current object, So right, so self is self. Then it is not required to provide or send or pass self as an argument to a method call. When we are calling that method, or you can say constructor, okay, so it is applicable for both constructor as well as methods. So it is not required to send self as an argument to a method call or constructor call. So by default implicitly that will be sent, okay. Self will be passed as an argument will be passed as an argument, and that is as a first that is as a first argument. Is that point clear? First argument right? So now, right, so let me move further. Print e dot name e dot ename so when I say e dot ename, what I'm going to get here? Okay, first, okay, I have given self. Now let me run this. Okay, let me run this. So can you guys see the complete thing? So I have a class employee, I have doc string, then all these are comments because we are talking about variables. Inside that we are talking about what? Instance variables. And where can we define instance variable? The point number one, I can define my instance variable. Here ename is instance variable, and where I am defining my instance variable? Inside a constructor. So the point number one, where I can define instance variable. So I can define instance variable, or I can define inside a constructor, right? So I can define instance variable, I can define instance variable inside a constructor. That's what one place where we can declare, define, or initialize instance variable, right? That's what we are seeing here. What is constructor here? Underscore in. For every class, this is a common constructor, right? I have defined that, and then I have a one line of print statement. Then I have initialized one name to my instance variable employee name with the help of self. So what is this self? So when it is when or who is calling this particular init, and when it is calling? So this is calling whenever we are creating a new object. So here I am creating a new object employee. When I create, so that init will be called. So called on what? So on this particular object. So here self is going to represent this particular e. So here e and self both are same. And again here, so again I'm creating one more object, right? Employee. This is another object, but I'm trying to keep assigning to the same variable or not. So that is wrong. So what I have to do? I have to make use of another variable e1. I have to make use of another variable, reference variable here. And at this point of line also, this also invokes what? This also invokes calls underscore init init. But what it is going to send? E1 is going to send. Okay. And here for the self, here what it will send? So here it sends, or it will pass what? E. So here in this case, E is nothing but self variable. Here E1 is nothing but self variable. Okay. So, and what object that init is going to happen? Okay. Anyhow, let me give one more clarity here. Whenever I say this employee creates a new object, right? It does two things. Okay. It does two things. This statement is going to do two things. So e dot employee, so it creates first thing is what? It creates an object or instance of an employee, the first job, employee, and that employee object is referred by what? E. Okay. E. Then the next thing is what? The next thing is what? So then after it is going to make use of that e dot, and it's going to call underscore underscore init. This is how it is going to call this particular specific method. Now the self variable, we don't have to specify this here explicitly. Internally, the Python takes care of it. Python takes care of it. So here, this is what the same exactly. Whatever the object I have created in the first line, right? The same object, using the same object, I'm going to call this init method by sending that particular e. So this e is nothing but self. Okay, this e is nothing but self, and we don't have to pass it. Okay, so these are the two things that this particular statement does. Is that point clear? Is that point clear, and are you following? So any questions so far? Yeah, I'm coming to that. So more than one parameter, and you should know what is the need of actually the multiple constructor. Okay, so let's go back. So here employee, right? So it does two things. So here invokes init of by passing what e, here init of e1, right? Now if I run this, right, I can see both objects are having what, Venkat and Venkat. Doesn't make sense, right? I have two employees. I have two employees. I have created two objects, and both objects are saying the name as what, Venkat. But I have, these are two different objects. I can say this is one object and this is one object, right? But both employee names, it's taking what, Venkat. Even if I create 100 objects, 100 employee objects, and it says 100 employee names as Venkat. True? Yes, right? So that is wrong. So for that reason, what I can do is, instead of hard coding this is kind of hard coding, right? So instead of hard coding this value constant to this particular employee name, so let me give that value when I create a new object, right? When I create a new object, let me pass my employee name. Let me send my employee name. So, but how can I send that employee name? So this method, this init method is calling whenever we are creating an object, right? Whenever I'm creating an object, automatically this is calling, right? So now, what is the way to send my own name to this particular employee? So that is where, so I can send along with my employee constructor. I can send along with my employee constructor. And of course, I don't have to send this parameter. I can send another parameter. So how can I send the another parameter? I wanted to send some name here, Venkat. And when I create another object, right? So here I wanted to send what? A different name. I wanted to send a different name, Sidhu. Okay, so this here I am sending a name here, and here I am sending a different name. So for what method or what constructor init, right? So init, I'm going to send a name from this particular init constructor. So who is calling this init constructor? When I create object, it internally calling this init method, right? So from where I can send this name to this particular init method. So when I send that particular name from here, when I send this particular name from here, Venkat, then internally it is going to send this Venkat to init like this. Internally it is going to send like this. All right. So here here you can see here you can see name as Venkat, and here I wanted to get it what, Sidhu. So here you can pass what, Sidhu. Internally, how it is going to invoke that constructor? Invokes init of e1 comma Sidhu. This is how it works. Now see, I am passing two parameters here, right? One is e and then my name, and here e1 and my name. However, this e1, e2, e3, so all these are going to represent by self variable. So that we don't have to pass as an argument here. So Python takes care of it. So what I have to pass? Only the name, whatever the name I want, right? So here my constructor is going to have two parameters, right? Here I'm sending two arguments, meaning that my constructor definition should have two parameters or not. So definitely self comma I need to have one more parameter. What is that? Name. So now that parameter is p name is going to hold the name whatever I am passing from there, right? So p name self dot e name equal to p name. Now see that the same thing I'm going to execute. So still why Venkat both the places? Because in the print logic I am referring what? E here, e dot e name, and here also I am referring what? The same e, not e1, right? So I have to refer what? E1 because I have two objects. Now you can see the output. Now you can see the output executing constructor and it is printing Venkat. In executing constructor, it is printing Siddhu. So are we good so far? So this is how you can send multiple parameters, Trikoti. So not only two, how many you want? Employee name, employee date of joining, salary. So as many number of things say as you want, you can send. So let me say employee ID. So I'm sending one here and I'm sending two here. Okay. So now when I say this again, this init method is going to pass this number here, right? This is going to send command. So this is what internally it is going to call. Again, my constructor is having three arguments, right? So definitely my definition also should change. My constructor definition also should take what? Three parameters. So I can say parameter ID. I can say parameter ID. Now I have to declare new instance variable. What is that new instance variable? I'm going to take it as employee ID. And of course, I have to declare it using what? Self variable, self dot this particular instance variable I have declared, and that declared variable employee ID I wanted to initialize it. So initializing with what value, whatever value I am passing from there, I wanted to assign it. So PID is the value that I'm sending from where? From my constructor. From my constructor. So this one is going to hold by this PID, or two, number two, employee two is also going to hold by PID, right? So now execute this and print. Now let me print employee name. Okay, so let me have some string. Name is equal something. Name is equal something, comma. Name equal something, comma. And let me print. Let me print ID. Okay, let me print ID. ID is equal, comma, comma, e dot eid. All right, so here also the same logic I'll keep it. So here, but reference variable is what? E1. E1. Okay, now run this. Now you can see the output as what? Name equal to Venkat, ID equal to 1. Name equal to Siddhu, ID equal to 2. So in this way, you can create, you can define as many number of instance variables as you want. So it all depends on your requirement. So excuse me. Yeah, so is that clear so far? Yes. Print e1 dot name in second print statement. Okay, that we did it already. Okay, done. So hope you guys are following. Right. So if you summarize it, we can send as many arguments number of arguments as we want. Okay, when to constructor to a constructor, right? No restriction, but first parameter must be self. First parameter must be self. Yeah, you can take that also, but first parameter, first argument first argument is self while sending, and defining while defining a constructor, first parameter is self. Okay, let's validate this. So if I don't declare this as a first, okay, what happens? Probably maybe you can try it out. Where is that constructor? Here. So here, so I don't have this one. I'm keeping it here. Right? Just playing it. I'm just playing it. So it started giving error, different errors. It's going to give different errors. Okay, so it is not recommendable. It's not about recommendable. It's a rule. Okay, so you have to take self as a first parameter. Self as a first parameter. All right. So, and one more thing I can say here is, right, so if I have 10 instance variables, so if I wanted to print 10 instance variables, I should make I have to prepare my print statement like this, right? So instead of this, we have some special thing here. We have some special things, e dot underscore underscore dictionary underscore dictionary. So if I print this, right, if I make use of this dictionary function, right, so it is going to print all the instance variables of this particular instance C. So in a similar way, so here also print e dot e1 dot underscore dictionary. See that beauty? See the beauty of this. So what I have used is a special function. What is that special method? Underscore dictionary e dot underscore dictionary. Now, so you can see that will be printed as a dictionary. Okay, e name, this is what value, and employee ID, this is what the value. So this is a dictionary. This is a dictionary. You can make use of this. That clear? Is that clear? Okay. Okay, let me take a new class to avoid all this. So new Python file. Okay, let me have student, some other thing, just student example. Okay, so now simple, you understand the basic things, right? Class student, I wanted to declare a class student, and here I can define a constructor. How can I define a constructor? Def underscore init self. So this is what my simple constructor, right? We know this. We have learned this so far, right? So what is the next thing? What is the next thing? Uh, I I told you, right? Instance variables are specific to the instance, right? Instance variables are specific to the instance. So if I say s equal to student, so now I have one object, student object. So here let me define name, student name, self dot self dot name equal to name, whatever name I am passing here. To avoid the confusion, just make it like this. So v name. Right. This we have seen. Simple. Now what I'm going to do is, right, I'm going to create one more object. One more object, student. So here I have to pass my parameter value or not. What is the parameter value? Name. So I'm sending the name. So here I'm sending the name. Okay. So I'm sending the names. I have two students, right? And if I print, you just know that. Again, let me make it as what as well. So we just seen that underscore dictionary, and again s1 dot underscore dictionary, right? Cool. So now you can see the names. Okay. Mm, what I executed is employee, I think. Okay, let me run this. Run as run student example. Okay, so name Srikar, name Madhavi. Constructor called two times and it's saying this. This is fine. Now I'm saying instance variables are specific to instance. So meaning that how I'm going to prove that. So I'm going to call s dot name. So name is defined as a instance variable or not. So I can make use of it out of the class. Okay, this is out of the class I'm using s dot name. If you wanted to access the class members out of the class, you can make use of that reference variable object instance reference variable dot the whatever you wanted to access it. So I wanted to access name here s dot name equal to s dot name equal to Shrikar. So I just wanted to give so Shrikar from Bangalore. Okay, something like this I have given. So I have changed the name. I have changed the name. Now if I print s dot underscore dictionary, what it is going to print. And if I print s1 dot underscore dictionary, what it is going to print. The same print logic I am using here. So here before the change, here after modified the name. Okay, for the instance variable what? Yes. So meaning that for the first object I have modified the name from Srikar from Bangalore, right? Now execute that. So here the output we have seen already, right? So here what is the output? Are we going to get for both the objects Srikar from Bangalore? Definitely not, right? So here first Srikar Madhvi, that's fine. Then after the name is what? Srikar from Bangalore and Madhvi is as is, right? Right? So whatever modifications you made, right? That is specific to that particular instance, that particular object. So you are using S, meaning that so in memory area, every instance has its own namespace. In memory, every instance has its own namespace. It has its own namespace. So here you can say class namespace or object namespace. So this is what I have two instances here. This is the namespace of instance. This is the namespace of this is the namespace of S. Okay, and here namespace of S1. Okay, and there will be a common namespace. There will be a common namespace called class level. So there is a class level namespace. Okay, class level namespace. Now whenever we are creating instances, right, so it has created separate namespaces, and in this particular namespace your data will be saved. So name equal to, so here it is having Shikar, and here we have the name Madhavi. All right. So, and this namespace is going to refer by what? This is going to refer by your S, and the other one is going to refer by S1. The other one is going to refer by S1. Okay. So probably who are already familiar with the object-oriented programming concepts and all these classes, objects, they may get little bored, but still there are many new who don't have any prior programming knowledge. Though they don't have any uh, this oops concepts knowledge also. So please cooperate and see. So now what I'm doing, so I'm reassigning the name by using the reference variable what s. So only the changes applies here only. So instead of this Shrikar, whatever the name I have given, this is going to replace Shrikar from Bangalore. That is what only it impacts this particular namespace, and it does not have any impact to this particular object. Understand? So that is what instance variables are specific to the instance variables are specific to the instance, so it does not affect the other things. Okay, now we have something else called static variables. We have something called static variables. We have seen this instance variable, and we also have static variables. So the static variables are also called as class level variables. The static variables are also known as class level variables. So here I am taking one more property, or you can say attribute, institute name. Okay, institute name. So I have declared this institute name as what? So JPS, institute name as JPS. Now let me print this. Am I going to get that? Am I going to get that as part of my instance, the dictionary? No, right? I'm not going to get. So if you wanted to see that, so I have to, yeah, I'm sorry. I have to, let me access that. So first let us see, uh, can I access that? Print s dot institute name. Am I able to access my institute name with the help of my reference variable or not? Yes, meaning that the institute name is available. The institute name is available for this particular S instance, right? Right. Now let me print s1 dot institute name. Yeah, this is available or not? So even for this instance also, that institute name is available. That institute name is available. Now if I print, so let me comment this portion, these two things. Let me comment out this because I don't need this dictionary stuff now. All right. So what I'm doing, so I'm printing. Still, I have something more. Okay, fine. So this is what the last two print statements, right? Print s dot institute name, s1 dot institute name. So JPS, it is printed both. Now, what I'm going to do is I'm going to change that particular name JPS to something else. Okay, how I'm going to change? I can make use of my class name directly. I can make use of my class name directly. So here, if you wanted to change your class level variable, use the class name directly. So student dot institute name. So I'm changing it to JPS Techno. I'm changing to JPS Techno. Now let us print the institute name for both, using both references, both instances, and see what is the output. Okay, so now you can see JPS Techno and JPS Techno. Yes or no? Is that clear? So this is what a class level variable. So institute name is what? A class level variable. This is a class level, or you can say static variable. Class level or a static variable here. Class level or static variable. Is that clear? Class level or static variable. So if you wanted to change this value, you have to make use of the class name. Class name is what? Student. Student dot institute name equal JPS Techno. When you modify this, right? So the changes are applied to all of its instances. So if you try to access s dot institute name, it's going to print JPS Techno. It's going to print JPS Techno. And of course, here also it's going to print what? JPS Techno. Right? Is that clear? If you are good, just I'll give one more point here. Are you good? Yeah, so everybody is good so far. Please respond in the chat window. Yeah, so Pallavi, are you good? Okay, all right. So now I'll show you one interesting thing here. So then I conclude this static variable. See, now I'm going to so by with the help of class name, I can change my static variable, right? My class level variable. So the question here, can I change the static variable with the help of instance? Is it accessible? Is it accessible from instance variable or not? This is instance reference variable, right? With the help of this Am I able to access the class level variable or not? Yes, right? Class level variable. So stat institute name equal to, I am changing it back to what? JPS. I'm changing back to JPS. Now again I'm printing s dot institute name, and also I am printing s1 dot institute name. Okay. Tell me now what is the output here? So is it going to print JPS? And is it going to print JPS because it's static variable, right? It's a class level variable. If you change that, it impacts to all the instances, right? The changes applies to all the instances, right? So is it going to print JPS here and JPS here? Is it? What is your answer? So see that, see the output, the last two lines. Okay, the last two lines. Just verify the last two lines. So one is JPS, the other is JPS Techno. It's not both the cases, it's not JPS. Okay, meaning that because I am trying to change the institute name only for this particular specific instance, not for everyone, not for everyone. So that is what the importance of namespaces. You have to understand the namespaces. Okay, here I just said this is namespace for instances, this is namespace for instance s1. Now so class level also has a namespace. That is what, this is what class level namespace. So at class level namespace all your class level variables will be created. Institute name. Okay, initially it was what? JPS. Now so here it's a class level, and every as it is class level, of course it's available for all the instances at the instance namespace. So here also you have institute name, and here also you have the property or attribute institute name. In both the places you have institute names, right? But what is the value it by default it may get is, it may get from the class level namespace by default. So this is going to use this particular value, this particular value. So this is going to use this particular value. Okay, so this is going to use this particular value from the class level namespace. And of course the other instance as well, of course the other instance also is going to use the same thing, right? So this is going to use it. All right, now so as it is using this same name, so it will be having JPS, and of course it also has what? JPS, institute name as JPS. Now if I try to modify, this value, using the class name, in the sense using the class name, then changes applies to class level namespace. Changes applies to class level namespace. That is what? Student dot institute name. If I call this, so this is, we are using this student class, right? Using the class name, if you are trying to change this institute name, so it is going to change what? It changes this particular value. It changes this particular value, and it becomes what? Whatever value or new value you are providing, right? So that is going to happen. JPS Techno. Now obviously this particular S and S1 is going to have the same name. What is that? JPS becomes what now? JPS becomes JPS Techno. JPS becomes what? JPS Techno, right? So obviously JPS Techno becomes what? So here also it will be JPS Techno, and here also it will be JPS Techno, right? Now, after this, what I'm doing? After this, I'm making use of this S reference variable. I'm making use of S reference variable to change the institute name. So as I'm using S dot, I can access this institute name, right? Using the reference S. So here I am changing it what? Back to JPS. Now, So what variable I'm using here? Yes, so the changes are going to apply to that particular namespace only, that particular instance namespace only. This is important point. Okay, even though institute name is a class level variable, the static variable, but it does not take the changes to all the instances. But in Java, it works in different way. In Java, it works in different way, but here in Python, it's a little bit different. If you are from Java, don't get confused. So here there is a small difference. So here, if you change this class level variable using the reference, using the instance, the changes applies to only that particular instance. If you wanted to make the changes applies to all the instances, then what you have to do is you have to make use of class name. That is only the uh, point here. You understand the story? Class level variable or static variable and then instance variables. Right? Good? Yes. Now let's move on then. Let's move on to other things. So we have seen class level variable, we have seen instance variable. Class level or static variable and instance variables. So what is the other thing we have? We have local variables. We have local variables. We have local variables. What is local variable? The local variables are the variables that are local to a function, that are specific to a function. Okay, function local variables. Suppose I am defining a function here. Okay, here in class we call it as a method. So let's say m1, and remember that if you want to define a method, even for method also, the first parameter should be self. Okay, so here I have a function here. Inside function I'm going to take one variable x equal to 100, x equal to 100. So here I'm going to print x. I'm going to print x, right? So if I call this method, s dot or s1 dot m1, of course I can call that, right? So what it is going to print? It's going to print that particular number. What is that number? 100. It's quite straightforward, right? So now, so if I have one more method, definition of m2, definition of m2 print x. Okay, print x. Now see this. What I'm doing, I'm not calling this m2, right? Okay, just m2, let's start m2. So execute this. So now it's giving error. What is that error? Name x is not a defined. Name error. It's a name error. Name x is not defined. Where? In this particular line number 11. It's giving error from what? Line number 11. Line number 11. What is the line number 11? So here we have x. So this x is not defined because so it is not an instance variable. It is not an instance variable. It is what? It is just a local variable. If it is either instance variable or a local variable, of course I can make use of it from any of the methods. So self dot, I can make use of name. Of course, here also I can make use of it, and even in other function also I can make use of it. Okay, see that. So here now I'm accessing what? Instance variable. I'm accessing instance variable. I'm accessing instance variable. Okay, so I'm able to access it or not? In both the methods. In both the methods, I'm able to access it. Okay, right. So this is M2. This is M1. All right. 1 second. All right. So yeah, so instance variables can be accessed in any number of methods, right? So because it's instance level, so here I'm using that particular name here in method m2 and here in method m1, right? In both the methods I'm able to access this. because it's instance variable, because it is an instance variable. So you can see that. Okay, so but local variables are local to that particular method only. You cannot access outside of that particular scope wherever you are defining, wherever you are declaring it, right? So that's what local variables are, a simple point, simple thing here. All right, so do you get some basic idea of what is instance variable, what is static variable, and then local variable? Are we good at this? Are we good at this? So if we are good at this, I will show you a few more things, different cases with respect to variables. Okay, still we have some more variable types. Okay, these are with respect to class. Okay, in object oriented programming. So apart from that, we have different scenarios. You can see different kind of variables. Okay, let me show you that variables. Okay, okay, so we have something called local variables that we know, and we have something called global variables, and we have non-local variables. We have non-local variables, and we have just seen what we have seen: instance variables, instance variables, class variables, or static variables. Then we have seen what? Instance variables, class variables, and local variables. Okay, fine. So these are the different kind of variables that we should understand in Python. Okay, interesting things. So there are different case. So to keep track of it, so I have already prepared a notes so that uh, we should not miss anything. Should not miss anything. So I just have. Yeah, so let me open this. Yeah, good. Yeah, so I have different things, different scenarios. Okay, I have multiple cases. Okay, I have multiple cases. So how it is going to behave depends on the context, the variable, how it is going to work. We'll see that. Okay, so let's start with case one. So accessing local variables outside the scope, right? So let me define. We're talking about what? Local variables again. Okay, so let me define a function. Now I'm not talking about classes. I'm not talking about whoops. Okay, just come out of that for some time. So I'm talking about local variables. So I have a function f1. I have a function f1. So inside the function f1, I am declaring a variable x equal to 10, and I'm printing that particular x. I'm printing that particular x. Okay, now I'm calling this function. It's pretty much straightforward, right? So I have a function definition here. Function definition has one variable, and I'm printing that variable. That's all. Now if you execute this, what is the output? It's very straightforward. Okay, let me execute this. It's very straightforward. What is the value? So 10. Understand? It's very straightforward, right? F1 value is what? Inside function 1, the value is what? 10. Now let me define one more function. Function 2. Now if I try to print this x here, and let me access it. So let me access it. So f1, f2. Okay, f2. Now print this and execute it. What it is saying? Same name error just we have seen, right? Name error. Name x is not defined because this name x is specific to this particular function. This is local to this particular function. So the scope of this particular x variable is within this f1. You cannot access out of this function. This f2 is a different function, so you cannot access this x from f2. The same thing we have seen with respect to the classes. Even though we have multiple functions inside a class, nothing but a methods, so the same rule is applicable. Okay, local variables are the variables whose scope is to that particular specific context where it is declared or defined. Right? Is that clear? Now, so that is what I have taken a case one here, name error we get. Then I have another scenario here, local variable. So here I have two local variables. Okay, so here again I am having what? X. So now is this fine or not? So now when I say F1, it prints what? It prints what? It is going to call function f1. F1 is having x value as what? 10, and the 10 is going to print this. Okay, and here again I have f2, and f2 is having another x 20, and I'm printing that. So here one more thing, important thing. So in allocating memory, right? In allocating memory or memory management, so it's going to have one separate stack frame, it's going to have one separate stack frame for every uh, function. Okay, for every function. So this is what stack frame for f1. This is stack frame for what? f1. f1. And in the similar way, if I have multiple functions, so I would be having what? Multiple stack frames. I will be having what? Multiple stack frames. So when I declared an x variable, so this is going to have in this particular, it's going to sit in this particular stack frame. So inside function f1, function f1, I have a x value, and x value is what? 10, and that is going to have in this particular stack frame. And in a similar way, I have f2. Inside f2 also I have x. So that is going to place in this particular stack frame. So this is how when you try to execute f1 function, it is going to read x value from here, and if you are going to execute f2, it reads from this particular stack frame. So obviously there is no errors. And happily it prints what? Both the values, f1 and f2. Okay, so let me have here also f2 to understand it a better way. Understand? Now I have f1, f2, both are going to show you the same value. Is that point clear? So this is a separate copy and this is a separate copy. Don't get confused because the value variable name is same. So now let us move on to other scenario. Okay, global variable. So now you may feel that, so here also we are using x, here also we are using x. So instead of making it local in two different functions, or making use of multiple places, it's better to define this as a local variable. You may feel that, okay, x value is 10, and whenever I want, I will change my value to my own. So initially my x value is what? 100. I have declared my x value as 100, but depends on the requirement. Inside f1 I'm changing the value to 10, and inside f2 I'm changing the value to 20. Now tell me what is the output. So f1 is going to print what? Still 10 or 100? Prints what? 20. Is it going to act as like this? What is the output here? Can you guys guess me? Now, can you guys guess me? So what are the outputs here? I have a global variable x. 100. And then after, inside a function f1, I have reinitialized that, and here I have reinitialized that in another function. And I'm calling both the function. F1 function I'm calling, and here these two lines will be executed, right? And x equal 10, it's going to print x value 10. And in this case, if I call f2, it control comes to here, and here x value is 20, and this is going to get that x value. Is that it is going to work? Can you guys tell me? So still you are getting the same outputs, right? Still you are getting the same output. So here The important thing you have to notice is important thing that you have to notice is, so this variable x is a, still it is a local variable, still it is a local variable, but not the global variable. This is a local variable, still it is a local variable, meaning that, so there is no relation between this x and this x. Okay, this is stored inside your stack frame, right? Stack frame, right? So and and every function has its own stack frame. It's kind of local until unless you specify this x. I'm going to consider this x as a global, so it will be treated as a local or to that particular stack frame, so this is still local variable. When you have a assignment like this, an expression like this, that is what a local variable. It's going to define a new variable x, and if I wanted to if I wanted to apply, or if I wanted to reinitialize my global variable in my function f1, so we have a separate way. Okay, so there we have to mark it as global x, declare the x as a global. Now what I'm saying, so my variable is what? Global variable. My variable as global variable, x is a global variable. Now see the outputs. Um, now now how it is going to work, and what will be the output here? So here, however, here I have a function f1, here I have a function f2. How do I get to know whether the value is changed or not? So can I print my x value here, because it's a global, right? So the x can be accessible to out of the functions. So here, mm, let me go back to that, the world scenario. Still it is a local. I just commented out this. Okay, so still it is considered as what? Local variable only. Remove this, don't get confused. So execute it. Now it's printing global x value, right? Global x value, global x value. So global x value is 100. Global x value is 100. Now, now, now what I'm doing is I'm trying to change my global x value. Okay, come on. So I'm changing my global x value, global x. Where I'm changing my global x value, I'm changing here. Global x equal to uh, 10. Okay, my my x value is 100 initially. Now my global x value is what? 10. I'm reinitializing it inside a function f1. Now what I'm doing in f2, I have x value, and I'm printing that x value. Then again I'm printing my global x value. Now you tell me, what are the outputs that I can see? What are the outputs that I can see? Hello, hello.
Hello.
I lost my connection actually. It's re-established just now. So is it audible now? Can you hear me? Should be fine now. Okay, fine. And my screen? Can you see my screen?
Screen is not visible.
Yeah. Okay, so something is
Screen is in struck mode.
hello. Yeah, fine.